as hypermetropia. And basically this defect is known as hypermetropia when you cannot see nearby object, but here this is coming due to losing flexibility of the ciliary muscle. So, we call it that is a presbyopia, but sometimes presbyopia may be both myopia as well as hypermetropia. So, sometimes persons are not able to see nearby object as well as far off object clearly, then also they are said to have presbyopia. These type of defects are corrected by using bifocal lenses. Bifocal lens is basically made of the both concave lens and convex lens. The lens has got two parts, upper part and lower part. Upper part is made of concave lens which helps us to see the distant object clearly, whereas lower part is made of convex lens which helps us to see nearby objects clearly. So, presbyopia sometimes may be the combination of both hypermetropia and myopia, or sometimes it may be only hypermetropia. So, now we have seen all these three defects. Now, see example, a person with a myopic eye cannot see objects beyond 1.2 meter distinctly. What should be the type of corrective lens used to restore proper vision? Also find power of corrective lens. So, here person has got a myopic eye and he cannot see beyond 1.2 meter. So, what happened in case of the myopic eye? I have told you the far point of a normal eye is infinite, but far point of a myopic eye reduces. Here that is 1.2 meter. So, first thing is here we can use a lens which is able to bring the image of the object placed at infinite distance to a point which is at a distance of 1.2 meter from the eye lens or from the eye. So, whatever is the type of lens you are using, I am not telling you that is a particular lens, I am taking any lens. For that given lens, object is also in front of the lens, that is at infinite distance, image is also at the in front of the lens, that is at a distance of 1.2 meter. So, we can take here for that u is equal to minus infinity because both are in front of the lens, v is equal to minus 1.2 meter. We know formula of lens, that is lens formula 1 upon f equal to 1 upon v minus 1 upon u. So, we can write 1 upon f is equal to 1 upon minus 1.2. Here this is minus 1 upon minus infinity. Does it make any difference here, this one, because this part will be 0. So, we can write 1 upon f is equal to minus 1 by 1 upon 2 meter. So, f is equal to minus 1.2 meter. So, lens we will be using whose focal length is minus 1.2 meter and sign is negative. We have done negative sign for focal length comes for concave lens. So, obviously, the lens is concave, that is, so we can write it, that is lens is concave. So, corrective lens is here concave. Now, we can calculate its power if we have got focal length. So, you know it, power is equal to 1 upon f in meters, already focal length is in meters. So, we can write power is equal to 1 upon minus 1.2 diopter, and that will be P is equal to minus 0.83 diopter. So, power of lens used for correcting myopic eye is minus 0.83 diopter. So, now this was an example related to myopic eye. Now, we will do another example which is related to hypermetropic eye.